Okay, we're on 10.1 notes, exponential functions, so you might want to print that out or have the copy in front of you. An exponential function, the base is always a constant. If you're thinking about what a constant is, that just means a plain number. Okay? And the exponent is the variable. So we have an exponential function if we have a variable in the exponent. All right, so it says sketch the graph of y equals 4 to the x power, then state the domain and range. The domain, when we're talking about exponentials, is always going to be all real numbers. There's no limit to what you can put into. Remember, the domain is your input, your x values. So there's no limit on what you can put into an exponential function. What is usually limited is what comes out. And so you kind of have to look at the graph to figure that out. So what I usually do is I look at this and I try to start with probably -1, 0, 1, 2, and I put that in. So if you do 4 raised to the -1 power, that's 0.25. 4 raised to the 0 power is 1. 4 to the first is 4. And 4 to the second is 16. Okay? I like to look at the range after I've drawn it so I can kind of have a visual of what's going on. So let's draw this one. -1 and 0.25 is about there. 0, 1, 1, 4, and then 216 is way up here. Now, if you remember back from Algebra 1, there is always a boundary that it skims along. In this case, the boundary, when you look at... Ooh, I don't want to make it that thick. Hold on, let me figure that out. Get that out of here. If you look at this on a graphing calculator, your boundary here is your x-axis. So your graph is going to look like this. It's going to start up high, and it's going to skim along the x-axis. So in this case, the range of the outputs is going to be all positive real numbers, because the y is all positive. If you look at that, you never get a negative y as your output. So the other way you could write that is y is greater than 0. So your range is all numbers greater than 0. A couple things to know about this. It is continuous. The domain is always the set of all real numbers. There's going to be an asymptote a lot of times in this graph. The asymptote was the x-axis. The range is the set of all positive numbers if a is greater than 0, and all negative numbers if a is less than 0. So again, if you draw it, you can kind of see that easier. The graph contains the point 0a. That means that a is the y-intercept. Okay, so you got to look for the y-intercept. That's usually where I look to start. And these graphs are reflection across the y-axis. Okay? Exponential growth. Is when your base is greater than 1. So if your base is greater than 1, you have growth. If you have exponential decay, if your base is between 0 and 1. So think about this. If your base is a fraction or a decimal, then you have decay. So you got to be careful when looking at these, because sometimes, oh, I forgot the L. Sometimes these can be tricky. So the base of this one is 0.7. That's between a fraction or decimal between 0 and 1. So that means this is decay. Okay? Now when you look at this one, the base is not 1/2. The base is what the exponent is on. So the base here is 3. 3 is greater than 1, so that's going to be growth. And then if you look at 4/3, be careful with 4/3, because 4/3 is really 1 1/4. So 1 1/4 is greater than 1, so this is also growth. So just be careful that you look at what's going on with each one. Okay? All right, let's talk about simplifying expressions. We're going to use the rules of exponents. Remember, a power to a power, you multiply. If you have like bases, you subtract exponents. If you have like bases, or if you're dividing and you have like bases, you subtract the exponents. If you're multiplying and you have like bases, you add the exponents. So in this case, what we have is division. Let me fix this one. We have like bases. So we're going to subtract the exponent. So this is 5 root 3 minus root 2. There's nothing you can do to simplify that one, okay? Because root 3 and root 2 can't go together. Now, the next one is a power to a power. If we're doing a power to a power, we multiply. So that's root 5 times root 6. So that's really 6 root 30 because there's nothing that can come out of that root, okay? The next part says property of equality for exponential functions. This is good for solving exponential equations. If b is a positive number other than 1, and you have the same bases here, then you can say that the exponents are also equal. If the bases are the same, the exponents are equal. This also works for inequalities. Okay? So here's the key. When we're doing problems like this, we look and see what the base is on one side. And more likely, most often, that means there's something I can do to make 256 have a base of 4. So what I do is I pick up my calculator and I start with something like 4 squared I know is 16, so 4 to the third, I believe that's 64. But if I go to 4 to the fourth, that gives me 256. So instead of writing 256, I'm going to write 4 to the fourth power. And the reason I knew 4 was the base, because it was the base on this side. Now, because the bases are equal, we have a 4 and a 4, we can say that the exponents are equal. 9n minus 2 equals 4. And then we can just solve that. Add 2 to both sides. 9n equals 6. And so our final answer is going to be 2/3 once you simplify it. Okay? So you're kind of looking for a clue here to see what you need your base to be. So let's come to this next one. Here's our clue. We have a base of 3 and a 9. Well, if most of you remember, I'm going to keep the 3 over here, but I'm going to make 9 into 3 squared. So I'm replacing 9 with 3 squared because I want the base of 3, and that's 2x minus 1. Okay? Now remember, a power to a power like that means we're going to have multiplication there. So that's 2 times 2x minus 1. And then I have 3 to the 5x. So I can simply say that 5x equals 2 times 2x minus 1. So you got to remember your rules of exponents as well here. And then we're solving. So we subtract 4x from both sides. We get x equals -1. Okay? Let's do this one inequality. Now this one you got to be careful of. There is a way to make 1 over 625 have a base of 5. We need that 625 to come out of the denominator, which means I'm going to have a negative exponent. So again, I get my calculator out and I just start testing. I know what 5 to the third is, and then I try 5 to the fourth, and 5 to the fourth is 625. So if I want 1 over 625, that would be 5 to the -4th. You got to remember your rules about whoops, this is a greater than. Sorry. You got to remember your rules about exponents. Now that we have like bases, we can just set this -3 to minus 2h is greater than -4, because if the bases are equal, we can have the same relationship is true of the exponents. Now be careful here. I'm going to subtract 3 from both sides. -2h is greater than -7. I'm going to divide both sides by 2. Remember, if we divide or multiply both sides of an inequality by a negative, we have to flip the sign. So this has to flip. And so really it becomes h is less than 3.5 or 7 over 2. So don't forget to flip your sign because we divide it by a negative. Okay, that should get you going on your homework. If you have any questions, you can always ask me. You need to do all the homework and you need to show the steps. Do not just give me the answer.